Welcome to our webinar this evening on Eco Retrofit for Householders, Unit 2 on airtightness. I'm really pleased to have our expert speaker, Diane Hubbard of Green Footsteps, to talk to us about airtightness this evening. And I hope, as you can see from this picture with the door and the air leaking underneath it, that we can give you some really useful ideas around making your home less drafty and more airtight this evening. So without further ado, I'll do a quick bit of intro. Diane will start talking about 6:10 and run until roughly 7:45, which is when we'll start with the Q&A. And so please bring all your questions, please drop them into the Q&A, and I will take you through those questions at the end, and we'll have about half an hour to run through all the different questions that we're asked. I'll put them to Diane, answer as many as possible, and then towards the end, about 7:20, I'll run a second poll and some other information, and then we'll close on time at 7:30. So for those of you who don't know very much about Cumbria Action for Sustainability, we do a lot more than talks about retrofit. We have all sorts of different projects. We've got a lot of different things going on. I'm not going to talk about any of those in detail right now. You can see from the pictures there that we do all sorts of different things, but I would encourage you to go and look on the website, on the CAF's website, if you haven't already done so, or you're not familiar with some of the things that we do. In terms of the Energy Services team, I'm part of the Energy Services team. We have a range of different services and projects going. Some things are free, some things are paid for. So on the free side, we have Cozy Homes Cumbria, which involves an energy advice call or visit for people who are eligible. Lots of people are eligible, so do keep in mind that's really helpful sort of run through and check of all the things that you might be doing to cut your energy bills and your energy use. We also do short general advice calls to people who've got one-off question about PV or insulation, something like that. Again, it's something that you could really, you can just ring up and one of our team can answer your question. I also do a retrofit consultation over the phone as well. So for people who are thinking about whole house retrofit, you've gathered a certain amount of information, but you want to just have a short conversation on the phone about that and run through the details, we can do that. On the paid for side, we have an energy audit service we use a product called Home Retrofit Planner, which is an energy model, and it works out the heat loss from your house, and under different scenarios, more insulation, different things done to it, can work out how much that heat loss might reduce. So that's something that we can do. Obviously that's a paid for service, as is our thermal imaging. And we run courses and webinars like this one. Some of them are free. This one particular is paid for by the Energy Redress Scheme, which is why it's free for you. But we're extremely grateful for anyone who makes a donation to CAFs when you do book on or at any other time, because it really helps us do more with what we've got. So it's really appreciated. So I'd like to start by introducing Diane before we start the talk and the presentation. So Diane is a mechanical engineer and really well up on building physics, and has been looking at this for quite a number of years. There's a master's from the Centre for Alternative Technology, and has been working as Green Footsteps now for quite a while, where she does the airtightness testing work, using a thermal camera in some cases, and can do energy calculations for buildings. And she's also got passive house expertise and a number of other relevant qualifications. So we're really delighted to have Diane with us here this evening, and she really is a mine of useful information. So without further ado, I will stop sharing my screen, and Diane, over to you. I'll make myself mute as well.
To unmute myself first. That's the problem. So You can hear me now, yes?
Yes, yes.
Good, right, I'll show it properly. Okay. Good evening, everybody. Hi, nice to see so many people here. Well, rather not see people here, but I know that you're there somewhere. Anyway, so yes, welcome. Anyway, hopefully you're going to gain some stuff out of this presentation. It's really great to sort of see the mix of people that are here. Some of you might find this, I mean, this is aimed at sort of introduction, really. So some of you might find we're recapping on things that you already know, but hopefully there'll be a little bit in here for everybody. Tina's kindly given a little bit of background, just recapping on that. So the reason I got into this originally, to be honest, was because I live in an old house and I wanted to know what to do with it, really. And I concluded that basically at that time people didn't know what to do. And so sort of my sort of the things I've got into have really been led by that sort of from that starting point. So I started looking at insulation to start off with, but then I quite rapidly realized that airtightness was something that we really needed to look at. And the other things I've done since have really sort of sprung from that. So I do the ventilation side of things because because of the link to airtightness. And it's important that we sort of model what we're doing properly, which is why the passive house stuff it is in there, really. So it looks a bit widespread, but there is a good sort of strategy through there as to why I've done all of those things. But that's my background roughly anyway. So what I'm going to talk about is airtightness. But what is airtightness? The thing we're really interested in is infiltration. And that's the uncontrolled flow of air through the gaps and cracks in the building fabric. And this diagram here is really helpful, and it shows the sort of typical things that we're looking at. So things like where the waste pipe leaves the sink, or under the back door, or around the windows, or the loft hatch. Or gaps around the extract fan, all those sort of things is what we're talking about, or coming up through the floorboards. So a whole range of things. And when we start talking about airtightness, it's the quantification of that infiltration. And one of the things I'm going to mention a few times is, one of the main ways of quantifying it is to carry out an airtightness test. Now, if you've ever watched Grand Designs, you'll see this test being done on new builds. And that's where it's mainly applied to new build properties. But there's a real benefit in looking at existing buildings as well using this method, because when we're talking about airtightness, people assume it's just about drafts, but it's about so much more than that. And I'll come on to that in a couple of minutes. But what we've got here, we've got a photograph of a blower door test, which is what that test is called. And on the right-hand side, we've got a couple of slides that show thermal images of the building when it's under those test conditions. So what we've got is the building is actually, the pressure is reduced inside the building compared to outside. And what's happening is that it's warmer inside, it's heated, it's a winter's day, and the colder air is being drawn through those cracks and crevices. And what we're actually seeing in these images is the cold trails of air as it comes into the building. So the top picture on the right hand side is of a floor wall junction, and it's the air coming under the bottom of the skirting board primarily, and then being dragged across the floor. And in the lower one, we've got a picture of a loft hatch, just a board sitting in a frame, how most basic loft hatches are constructed. And again, what we're seeing there is the cold air that's coming around the side of that board and then into the occupied space from the cold loft area. So what we're seeing here is it's sort of the thermal imaging camera is actually showing what's happening under these test conditions. So but that doesn't relate to reality, really, does it? But having this test on the building, but what the difference in pressure actually is that the fan creates in the building is the equivalent of sort of a wind of about sort of 20 or to 30 mile an hour wind. Now, recently, we've clearly had those sort of conditions. In normal times, when the wind blows, you would see, maybe you'd feel the drafts on the windward side of the building. But on the leeward side, the air would be leaving, so you wouldn't be aware of it. So your perception in your home, say, on a windy day would be that that particular window on the windward side was leaky, but you wouldn't be aware of it leaving on the leeward side out of a door, say. But what the test does is it applies an even pressure to the building as a whole. So you can judge all of the characteristics of the building quite uniformly and then judge their impact on the building. So it's a very handy test to actually carry out. So why do we need to focus on air tightness? Why is it important? We all know about drafts. And that's sort of the first thing that we all go to. If you've got too much air going through your actual living space, then it's going to be uncomfortable. The physical exchange of air is going to increase your energy use. But the other thing is that in terms of thermal comfort, if you're sitting in your lounge and you have a draft across your ankles, then your reaction is to perceive that the air temperature is lower than it actually is. And so you tend to reach for your thermostat and increase the thermostat, whereas actually it's a localized draft maybe that's affecting you. So there's two sort of particular aspects that are relevant in terms of direct effect on us. But there's a few more things we need to bear in mind. So if you've actually got air moving through insulation, so say loft insulation, your normal sort of insulation bats you'd have above a flat ceiling. If you've got air moving through that affects the performance of that insulation. So you don't get the insulation value that you would expect to get. And particularly when we're looking at maybe retrofitting internal or external wall insulation, you could be spending quite a lot of money on doing something. And if you've actually got air routes through that insulation, it will affect how well it performs. So it's important from that point of view. Another side of it is that what you could have is, in your home, the air is relatively moist. It might be warmer than outside, but in terms of what it's carrying in terms of absolute moisture levels, it's going to have a higher moisture load. And if that warm air then travels into your building fabric, as it cools, there's a risk which it's going to condense somewhere where you don't want it to. So it might condense around timbers in the structure, say, and that increase in moisture level could then shorten the life of either the building as a whole, or it could shorten the life of that particular upgrade. So ensuring that the unwanted air from the inside of the building doesn't get into the building fabric is quite important. Another side of it is making sure that the ventilation system performs. More and more of us are sort of looking at more complex ventilation systems, and as our air tightness of our buildings improve, we do need to focus more heavily on ventilation. But that ventilation has got to perform in the right way. And if we've got a high level of infiltration, if we've, say, got mechanical ventilation with heat recovery, then it's not going to be recovering all of the heat it possibly should. If we've got air routes through the building fabric, so you'll have made a significant investment in some equipment there, and unless you've got a good level of air tightness, it's not going to be performing at its best. So I need to sort of talk a bit about numbers for a while. So apologies to people, but it's important that sort of you understand a context, really, I think, because it will aid your further thinking. So the blower-door test, I prepare the building exactly as it's prepared for a new build property. Now, what that means in retrofit is that we're often covering things that can add quite a lot to the airflow through a property. So things like you might have an open fireplace, which clearly could draw quite a lot of air through. You've perhaps got extractor fans. You might have a boiler that's drawing air from inside the property as well. You might have a stove. These are excluded from the test because what we're trying to do is to not measure how much impact, say, an open fireplace has. We're trying to measure the fabric, how leaky the fabric of the building is. And what you can then do afterwards is sort of add back in those impacts, really, of the other things, and think about them separately rather than lumping everything in together. So it's worth just highlighting that really we're looking at the fabric itself, not the things where it's a deliberate item that increases the airflow through the building. So working to exactly the same protocol as for new build. And there's two ways of quantifying it. And the normal way from building regs in the UK is something called air permeability. And that basically is the flow rate that something like the fan on the right-hand side generates. So that's an airflow in meters cubed per hour. And it's divided by the dwelling envelope. So that's the floor, the walls, and whatever's happening at the ceiling, the top floor ceiling. So you've got the whole envelope it takes into account. That can be quite difficult to relate to, as somebody who's new to this. And one thing that's easier to relate to is actually air changes per hour, which is comparing the flow rate of the fan to the volume of the building as a whole. So you can sort of think of it as to how often the air is actually changing within the building, how many times an hour it's changing when that pressure is applied. The 50 pascals is simply the pressure difference that is being applied by the fan. 50 pascals between inside and outside. I normally operate it as depressurization, so below outside, but you can do it the other way and pressurize inside the building. So one of the things to sort of think about is the air permeability and the air change rate can be quite different things. So we've got two buildings here. We've got an L-shaped bungalow on the left-hand side, and then we've got quite a boxy house. It's quite cuboid. And in the property on the right-hand side, if you do the calculation, you'll see that the surface area of a cuboid like that house is roughly the same as the volume in number terms. But if you've got something like an L-shaped bungalow, that's got quite a big surface area compared to the volume. So the form of the building starts to become quite important when you're looking at sort of putting figures to airtightness. So bear that in mind when you're considering your home. What's the form of it? And is that in itself likely to have an impact? And I suppose the importance, which do you use if you're looking at your own home? Well, it depends on what you're after, really. The air permeability, which relates it to the surface area, is quite helpful because, yeah, it is actually the fabric. It's what the outside of the building is doing. But if you're thinking more about maybe how much ventilation you need, or you're thinking about mechanical ventilation, you might want to think of it as an air change rate. So it depends on what you're actually after as to how you should consider it. So what I've got here is some numbers that I think will help us to sort of put it into context. We'll forget the units for the purposes of this discussion. We'll think of it as a cuboid house. Okay, so passive house has to come in at better than no worse than 0.6, and that is air changes per hour at 50 pascals. When we look at our new build requirements, the limit is 10 meters cubed per hour per meter squared at 50 pascals. So a figure of 10. It's quite rare that new build houses have to come in at that. It's more typically, you know, for a typical sort of estate type house on gas, that they typically have to currently come in at about 5. The regs are changing partway through this year, but that's currently what they have to do. But if you say looking at mechanical ventilation with heat recovery, there's an expectation there that you're really looking at properties that are coming in at 3 or better to make it worthwhile. Now, a lot of the work, I'm not particularly going to talk about it today, but a lot of my research, my academic research that I've done is on traditional buildings, so pre-1900 houses. And one of the things that my academic research did was people assumed that older houses were going to be much, much leakier than what we're putting up now. And my conclusions are you get some bad ones, but actually they're nowhere near as bad as people think. And basically people hadn't tested them. And so they were making lots of assumptions about how bad they were going to be. And so what I've done is I've now tested hundreds of existing buildings. So I've got a pretty good feel for where things stand. And roughly about a third of unrefurbished pre-1900 houses come in at 10 or less, and some come in much better than that. Some are horrendous, but the worst house I've ever tested was built in 2015, and that came in at 36. So there are some quite dire houses still being built out there. That one didn't need to be airtightness tested, and that's the reason why that got through, but horrendous for the householder. But unless you test, you don't necessarily get a feel for what you've actually got in your building now. So these are some examples of houses. So we've got 2 new build houses. These ones on the right hand side, and we've got 2 older houses. And you sort of say, well, which has got the best air permeability? That new build one's probably the biggest house. That one's probably the next one. That's just a bog standard 30 semi. And then we've got this late 19th century semi as well. So it's quite interesting. I mean, the 30s semi, when I tested that out, the air permeability is just under 15 on that. So that's not great. That new build there, that came out at just under 5, about 4.9. This new build here, well, that came out at 6.1. And this 19th century semi with original windows, well, that came out at 5.6. So you can sort of see, I mean, we're clearly talking about different insulation levels on properties, but in terms of airtightness, we've got, you know, that the brick built semi is not the tightest, but it's not that far off that new build that was built in the last couple of years in terms of airtightness. So don't assume that old buildings are leaky. So this is a photograph inside that new build sort of detached with the integral garage that I've just shown you. And one of the problems that we have with the way that we build houses now is that we're using plasterboard a lot. And the way that plasterboard is commonly fitted in is using a method called dot and dab, basically dabs of adhesive onto the wall, and then the plasterboard is stuck to it. Now, all the official guides say that the plasterboard should be edge sealed, so a continuous line of adhesive all around the perimeter of the plasterboard. But invariably, it's not fitted in that way. And what the image that we've got here on the left-hand side is the detail of this corner here. I hope you can see where my cursor is. So it's the detail of that corner we're looking at. And what we're seeing here is the building is depressurized. So my fan is going and it's taking air out. So the pressure in the building is below the pressure outside. So it's pulling cool air into the building through those cracks and crevices. And this is on the first floor. It's in one of the bedrooms. And what we're seeing here is we've got cold air going behind the plasterboard, and then that's coming out in places like sockets or at the floor wall junction. And you can see we've got some quite serious temperatures. Really, it was a reasonable winter's day, and from this temperature point here, we've got a temperature of 19 degrees on the wall, but in that corner we've got 14 degrees. Now that difference is enough under normal conditions to virtually prompt mold. It's getting to the point where you could get mold in that location, and that's on a new build house. So plasterboard can create, if it's fixed by dot and dab, can create some serious issues behind the serious issues with reduced wall temperatures. And that thing that I was saying before about it bypassing the insulation. The insulation is in the wall. The air is being drawn down from the roof void behind that plasterboard. So you're bypassing the cavity wall insulation, basically. So the fuel bills in this property will be higher than they should be, than the calculations show. So in older buildings, what have we got? We have plaster. Now, the thing is that all common building materials, so stone, brick, blocks, they're all air permeable. And so when the wind blows, you will actually get air moving through those walls. And the thing that stops the air movement in older buildings is the wet plaster. That's the layer that stops the air from moving. So if you remove that plaster and say put dot and dab plasterboard on top, you're going to get air moving behind the plasterboard. So when you're thinking about retrofit, you need to realise that plaster that's there already is actually fulfilling a role from an airtightness point of view. And I realise, builders are not that keen on wet plaster, but plasterboard, just use of dot and dab plasterboard can really compromise the performance of some upgrade works. So there, it's the plaster that's the airtightness layer. So that's a fundamental thing to be aware of. So how do you achieve airtightness? Really, there's 4 key steps in doing that. You want to know where you're starting from, really, what your target is. You need to develop a strategy to achieve that target. And then it's down to making sure that there is quality assurance, really, or the workmanship on the site achieves your aim. So know where you're starting from. So this is an example of a property that I looked at a while ago now, where it's a 1990s barn conversion that had a couple of extensions in the early 2000s. And the image on the right-hand side is a thermal image when the building is depressurized, so the fan is going and it's air is being drawn into the building. And this photograph is taken in this portion of the building, so one of the extensions around the year 2000. And that has a sloping ceiling with a flat surface in it. And we can see a lot in this image here. So we have a very nice looking beam that's got air leakage all the way along it. So we've got these cold trails of air coming down that side, and the side we can't see, it's the same thing applied. We have some integral light fittings that are leaking here, and the insulation has been held off around the light fittings. So when it was sort of halogen fittings, they were throwing out quite a lot of heat. So there was a requirement for the insulation to be held back off those. Now we're LEDs, not chucking out the same amount of heat, so the insulation can be treated differently. But this is all sealed, this spaces, they can't get into it. And we've got areas here. What we're seeing here is we've got timbers, the roof timbers going across here, and we've got whole areas where there's insulation missing from within the void. So we've got a whole combination of things here with air leakage and missing insulation. But without that, without having done a test, you wouldn't know what you've actually got there. You'd think it was built in the early 2000s, it should be fine, but actually it's quite problematic. There's no requirement to test existing buildings at all. Airtightness test, no requirement if you build an extension to test things. It's purely a requirement for wholly new build properties. So there's no sort of control other than the normal building regs procedure for how to deal with airtightness in extensions. Here's an example of a property I looked at, I've looked at in the last couple of months really, where the client was about to refit a couple of bathrooms and looking at internal wall insulation, and I had a look at the building just before they started the works. And this is a classic sort of example. If you can cast your mind back to that first slide, one of the things that sort of it showed was air movement related to holes in walls for waste pipes and that sort of thing. And the image on the right sort of shows the way that the cold air is literally falling and being drawn around the bath panel here, which is it's a timber bath panel. And though we didn't take the bath panel off, my conclusion is that the air movement is likely to be coming through a combination of the floor under the bath and where the waste actually leaves the building. But fortunately, the client was they were about to sort of change the bathroom fittings. So they were sort of alerted to checking everything out before the new bathroom was put in. But we can see the cold air there, we can see those fingers. But the client is better informed now for the next stage of their retrofit. So a picture of that semi again, that brick-built semi, and this is part of a larger project where that building is being treated as a pilot for a large group of properties on this particular estate of buildings, and it's undergoing a deep retrofit. But the assumption until this test took place was that actually the buildings were going to be more leaky than the test actually found. So that result has changed the approach that's being used for this particular property, and that pilot then will be used for the rest of the buildings on that estate. So knowing where you're starting from is really important, because it shows you how you should direct your money. If you've got a building that is more airtight than perhaps you assumed, then it sends you in a direction more of ventilation, and you're not spending money on things that look at airtightness. On the other side of things, if the building is more leaky, then it sends you in a different direction. So it's a great tool for determining wise expenditure, really. What should you spend your limited resources on? and think about the target, then what, you know, we're talking about the planet. This is a personal decision from your, you know, from your viewpoint. So it's not down to, you know, there isn't a right answer here. It's what's motivating you. Are you trying to do the best you can do? Are you trying to get a certificate? Are you wanting to comply to Enefit, which is the passive house standard for retrofit? There's an AECB standard that you could go for. Are you interested in getting a badge, or do you just want to halve your fuel bills? What's your objective? And where does the airtightness then fit into that? So that's a personal decision, and something that you need to think about what you're trying to achieve. So the next thing you've got to do is to develop a strategy. And this applies really to new builds as well as existing buildings. So it's the same house I showed you before, which is it's a new build property, that is, or a recent build. And the important thing is that it's designed in from the outset, the airtightness is. So as soon as you start thinking about how you're going to retrofit your home, you need to start thinking about your airtightness strategy. Whether you're doing it yourself, whether you're working with an architect, it's got to be an integral part of it. And it isn't all about fancy materials. So in this house, which just out of interest got a final test result, I think about 0.4, he used bog standard materials, mainly bog standard stuff that you can get from Travis Perkins. So he was trying to use standard materials as much as possible. It was wet plastered, and that was the bulk of the airtightness layer. He used specialist tapes in places, but he tried to use standard material as far as possible. But these special materials, now I'm hoping you can see, can you see me? Or I got to come out of, can you see me?
What we can probably do is we can swap the video in the shared screen.
Okay.
It might be that other people can do the same, so they can make you.
Okay, so you don't need to. So if I waft things around, that's what
lift it up a bit. Just lift it up a bit.
Okay, right. So I'm going to start talking about more specialist materials. Okay, so people go on a lot about airtightness tapes, and you sort of look at them and you think, my goodness, that's a lot of money for something that doesn't look very substantial. The thing to think about is what we were, that drawing at the beginning. A classic location for air leakage is around windows. A window, sitting in a window reveal, and the sun shines through that window, and what happens is everything contracts and expands over time. So the window expands at a certain rate, plaster expands at a certain rate, the windowsill expands at a different rate. And what happens is that over time, that crack opens up and it's an air leakage route into the building. And that's repeated in all those locations around your home. And the thing that airtightness tapes do is they go on behind the scenes. You don't see them when it's all finished. It's all hidden behind the plaster or plasterboard. And what they do is they cover over gaps like that. And they have the flexibility to cope with that movement over time. Their lifespan with a good quality tape is, 50, 60 years. It's the life of the building. I mean, our new builds are designed to a 50-year lifespan. So it's designed to work behind the scenes. So it overcomes that contraction and expansion. So these are really valuable. They're actually really quite straightforward to use. They come in different types. It depends on what you're gluing to what. This is a general purpose one as an example. You get ones that are sort of split like plasters. So they have a split down the middle, so they're easier to apply to window frames, say. You get specialist things like if you're putting in an outside light, you get things like this, which is basically has a small hole in it that you put a cable through, so the electrician can pull a cable backwards and forwards. He can fit a light. He doesn't see any difference. And this just sits on your airtightness layer. Again, it's hidden behind the scenes. And if you want a wood burning stove, say, with an external air intake, you know, you've got, or for your waste pipes, you've got gaskets like this, that when you're putting the waste pipe in, you just squeeze, it just goes over the waste pipe, and it then gets taped to the airtightness layer. So there's quite a lot of specialist stuff around. It's not cheap, but it does quite an effective role. I mean, I've been into quite a lot of properties, and where a cable has gone through the wall, if the builders try to do something with it, there's usually like a massive foam around, spray foam around where the cable goes through. Actually, something like that is a lot easier to do than spray foam around it, and it's an awful lot more resilient. So these really do have a role. You do get different qualities of airtightness materials. Quite a lot of the cheap stuff you find is quite susceptible to high humidities, and it loses its bond. So it's a good case here of you get what you pay for, really, with specialist airtightness materials. So I wouldn't scrimp on that, because it's going to be there for the long term. It's sort of heartbreaking when I test a property, say a new build property, where cheap airtightness materials have been used, and by the time I carry out the test, they've failed already. And that's not an uncommon thing to happen. So don't scrimp on the fancy materials. There's a lot you can do without the fancy materials, but they have their place, and don't scrimp on that side of it, really, because it's a false economy. So what do you do? You've got to develop your strategy. So basically, you need to think about your home in 3 dimensions, and get a red pen and literally draw where your airtightness layer is on your home. Now, this doesn't just apply to if you're looking at trying to achieve, NFIT, the Passive House Retrofit standard, or any other standard. It's a good way of thinking about it generally, because you would be quite shocked at how much air does actually come in through the gap at the floor, or through where the light fitting is. So develop yourself a strategy for airtightness. So get that pen and literally, where is your airtightness layer on your home, and do it, not only for, in this section, but also for each elevation. And every point where you've got a junction or something going through, you need to think, how am I treating that? Where you're looking really good levels of airtightness, you'd be looking at these sort of things and gaskets. If you're looking at sort of just achieving a moderate level, you'd say, well, for that kitchen waste that's going through, I want to make sure it's well sealed around it. It's got, it's been foamed in place, or there are ways that it's been dealt with. It's been thought through. I mean, it's well worth investing your time on developing that strategy yourself, and then you need to make sure it's communicated to whoever's doing the work if you're not doing it yourself. But well worth committing the time to developing that strategy. So the final part of it is it's getting that, making sure that you get the workmanship on site, okay, whether it be you that's doing it or somebody else. So what we've got in the picture on the right is we've got a window frame with tape applied to the reveal, and then we're going to be plastering over the top, so we won't be seeing any of this tape after it's all finished. So in terms of sort of achieving your goals then, so you need to be clear with everybody about what you're aiming to do. So you can't sort of assume that people know what you want in terms of airtightness. You need to make sure that they know and go through, explain what you've done in terms of thinking through the strategy, your red line and all this. And people often then get on board with it once they understand what you're trying to achieve. On a larger site, or if you're doing maybe a whole house retrofit, you'd have somebody who sort of becomes the champion, really. Now that might be the builder himself, it might be one of one of his members of staff, it might be you that really takes on board making sure that the airtightness is prioritized. It's important that everybody knows that there's that everyone has a responsibility with the airtightness. Not that there's any, you don't want to blame structure, you just want people to understand what you're trying to achieve and that everybody can make a positive contribution to that. But the other side of it as well is if something is accidentally done, you need to really, it needs to be a culture where people know that they're not going to get blamed or anything or penalised by highlighting, because what will happen then is problems would get hidden. So it's having quite a positive approach with everybody, that if something goes wrong, people need to tell you, really, because accidents happen, and it's important that you're able to get it sorted while it's all accessible.
Diane, can I just check with you, because we've had one person ask if the slide can be made any bigger. So I just wonder if only one person's having a difficulty with enlarging the slide, or if everybody's seeing it as a bit small. I don't know if it can go any bigger. I can control it on my screen and make mine's big, but
I could revisit it in the questions. I mean, hang on. To be honest, there isn't that much detail on it. I mean, it's just 2 layers of tape, and so
yeah, okay, that's fine. I mean, if anyone swapped their speaker view round with their slide view, they might need to swap it back if that's the problem. But otherwise, I'm seeing this big, so I expect most people, other people are saying the size is fine. So I think it's just individual laptops or computers have got things on different sizes. I don't think it's, that's brilliant. Thank you. No, it's okay. There might be scope to make it bigger if you're struggling, just by changing your own view of your individual laptops. That's fine.
Yeah, so just sort of recapping, you try and break it down into those 4 stages. Know where you're starting from, because you could be in wildly different place from your neighbour or from your friend who's just retrofitted their house. Decide what you're aiming for. You can develop the strategy. That's something that you're able to do yourself, and then make sure the implementation is good. Break it down. But the thing is, it's not all about airtightness. So you need to think, you can't think about airtightness in isolation. You need to think wider than that. And the example I've got here, this is a property that had a deep retrofit, and this is the fan in the bathroom, which sort of provided a background flow rate of air in the building, and then had a boost setting, so when the shower was being used, the airflow rate ramped up. But there were some issues with that, and it actually has a very fine filter on it, and so you're asking that fan to do quite a lot. And this was an example where I used sort of data loggers and things, looking at what was actually happening. We realised that the fan had been set incorrectly as well. So there's lots of other things you've got to look at. You cannot look at air tightness alone. You have to look at it in combination with ventilation. You're also looking at fabric, thermal performance as well. So you've got to look at everything as a whole. Great, okay, and that's me, and that is the end of my presentation.
Thank you so much, Diane. That's been really interesting and really clear, and some really great images there that really sort of bring to life how this works. Because of course, this is all invisible in our homes to a very large extent, and it's only when you start to knock things about a bit or get out a thermal camera that you start to see what's really going on. So thank you so much for that. That's been really interesting. If you've got other questions that come up, they might be covered in our next webinars, or you might want to talk to us about an advice call with somebody at CAFS on retrofit, or just a one-off question. And you might also want to ask us to quote for our full energy advice audits. So the contact details are there, and we will be emailing out, as I said, in about a week's time. So all the contact details will be on the email as well. Don't need to worry about getting it all down now. We've also got a Facebook page, so look out for that. First of all, our webinars, our next webinars, we've got the rest of this series covering insulation, ventilation, and for anyone who missed the first unit, the introduction, that's being repeated on the 14th of March. We've got 2 webinars on Windows, starting with choosing high-spec windows, and secondly, how to install the windows well, whatever windows you've got. And then we'll have more, particularly for builders, in April and May, and a few more webinars for householders after Easter. So you can book onto all of those through the CAFS events page. And what I would say is sign up to our newsletter. The CAFS newsletter always contains information about the forthcoming events. So that's a way you can get those that information prompted, remind yourself. We'll send out links to our Facebook page if you're interested in a Green Build Facebook page. The next steps, do sign up, join a webinar. In the email that I'll be sending out, there'll be a survey for your opinions, which you can fill in with your name or anonymously as you prefer. We really want to get your survey responses if you haven't already done it. That would be wonderful. Do contact us if you want any other questions. Thank you so much to everyone who's made a donation. I did pop the donation link into the chat if anyone's interested. It's on the CAFS website. And really, just to finish, thank you so much, everyone. Thank you, Diane. Thank you to everyone who's attended, who's listened, who's asked a question. And we really hope to see you next time when we do another webinar at some point, one of the other webinars in the future. And have a good rest of your evening.